Okay, let's dive into this. Because right now, we're witnessing an absolutely unprecedented shift in global energy demand. And it's being driven by something we literally rely on every single second of the day: data centers. In this explainer, we're going to look closely at the rapidly escalating challenges power utilities are facing as they scramble to expand their generation and transmission capacity. But we aren't just going to look at the problem, right? We're going to explore the solutions. We'll unpack the new Utility Playbook, looking specifically at how utilities are using absolutely every available lever, including some incredibly innovative technologies like advanced thermal storage and low-energy cooling, to totally modernize the grid. So, how much power does the cloud actually need? To really grasp the massive scale of this crisis, we've got to look at the evolution of modern computing. I mean, we all know the cloud requires physical servers, but this sudden explosion of AI and high-performance computing, it has completely changed the game. The density and the thermal management requirements for just a single rack are absolutely skyrocketing. And honestly, this is setting the stakes for what might just be the greatest infrastructure challenge of our time. Now, what's really interesting about this slide is just how fast this growth is hitting hyper-localized areas. Take Cheyenne, Wyoming, for example. Right now, their power grid has a peak demand of about 300 megawatts. But with major players swooping in and buying up thousands of acres for new data centers, that anticipated peak is projected to jump to 4 to 5 gigawatts in just the next 5 years. That is a 15 times multiplier. Just think about that for a second. Think about the sheer amount of infrastructure required to support a 15x increase in power in just half a decade. It's wild. To truly grasp why utilities are struggling to keep up with this, we kind of have to look at their history. For decades, literally decades, utility companies only saw very modest, predictable net growth in power demand. Because of that, they naturally developed a highly regulated, pretty conservative mindset. Their main job was simple: maintain grid stability and keep the lights on. Any big changes required long-term, complex planning. But over the past few years, that cautious mindset has been completely upended by frantic, historically unprecedented load spikes from these data centers. Utilities are now being forced to move incredibly fast to generate and transmit power, all without risking service or affordability for us, their everyday customers. Let's take a look at how this is actually playing out across the country. Up in Cheyenne, there's actually a pretty welcoming mentality from landowners and power brokers, but they've had to create specific funds that data center applicants must pay into upfront just to protect local utility rates. Down in Texas, Oncourt is facing this massive wave of applications. We're talking 122 gigawatts already secured, and another 150 gigawatts sitting in the pipeline. But look at that bottom row. Phoenix, Arizona, a utility that currently has a total absolute max capacity of 8.5 gigawatts, they're sitting on a staggering queue of 12.5 gigawatts in new applications. Let that sink in. And this brilliantly illustrates the sheer visual stress on the grid. When you chart it out, you can really see how these pipeline requests entirely dwarf the existing utility infrastructure. That first bar is literally everything they've built over decades. And the second bar is what they're being asked to provide basically right now. It's like trying to fit a fire hose into a garden hose. So this sheer volume of requests is obviously creating massive bottlenecks. But here's a fascinating little detail. Many data centers are actually putting out multiple requests across different regions just to guarantee they get capacity somewhere. And that artificially inflates the overall aggregate view of the demand. It's a gold rush. So utilities are caught in this absolute race to adapt. They're exploring some pretty extreme measures just to keep up. Things like extending the life cycles of older retiring plants or converting coal plants over to gas. Plus, because of this gold rush mentality, not all project requests are from serious, viable players. Utilities are having to rapidly change their vetting criteria, demanding hefty upfront financial deposits, and really prioritizing projects that actually provide a distinct benefit to the grid. And of course, this rapid expansion isn't happening in a vacuum. Because of all this, data centers are starting to face a pretty significant public relations problem. Local communities are rightfully getting concerned about their own utility bills spiking, the massive amounts of water consumed to cool these facilities, and the broader environmental impacts. Now, while this is primarily a data center issue, it's the utilities that are caught squarely in the crosshairs. They're being tasked with solving a PR problem they didn't even create. As a result, data centers are actively hunting for friendlier regions to set up shop. But here is where our narrative shifts from a crisis to an opportunity. At recent industry gatherings, it's become super clear that pioneering utilities are not just throwing their hands up in defeat. No, they're approaching this with an open mind and what they're calling a leave no stone unturned mentality. They realize they have to completely reimagine grid architecture. They need to find ways to shift some of that variability control away from the grid itself and push it back onto the data centers and other large consumers. Let's move to and see how this builds into the new utility playbook in practice. It starts with incredibly smart new technological levers, like the thermal kink from Thermal Energy HQ. Now, on the surface, sure, it might look like a standard hot water storage tank, but it has been completely reimagined from the ground up. This is the very first high-performing, truly modular thermal battery of its kind, and it's exactly the kind of innovation utilities are desperately looking for to expand intelligent thermal storage in both business and residential settings. So the crucial point is these four core pillars that make this such a powerful lever for the grid. First up, practicality. It's incredibly lightweight and modular. Then there's price. It easily beats the competition on a dollar per kilowatt hour basis and is actually eligible for ITC incentives, which is huge. Performance is massive too, boasting incredible insulation values of R18 and up. And finally, planet-friendly. It has a vastly lower carbon footprint than traditional steel tanks, and the whole shebang is 100% recyclable. What really makes this so powerful for utilities is the design itself. By completely removing the need for pressurization, the thermal tank lowers maintenance requirements and allows for this really unique modular setup. It can actually be shipped in components and assembled right there on site, easily fitting through narrow passages and into super tight spaces. Why does that matter? Because easy on-site installation allows for much larger thermal storage without making a building's mechanical systems overly complex. And larger storage means you can bank a ton of thermal energy during off-peak, low-rate cycles. That allows both the customer to save money and the utility to avoid those massive peak demand spikes. It's a win-win. But as we know, a battery is really only as good as its management system. We've seen a real evolution in controls over the years, moving from your basic manual thermostats to fixed schedules to smart apps with some basic automation. But to truly relieve grid strain, we need the right side of the spectrum. We're talking about time of use optimization, where grid interactive options respond directly to utility pricing signals in real time. And finally, step 5, coordinated control. This involves supervisory controllers like Solera controls integrated with these thermal tanks, rapidly orchestrating multiple heat pumps and storage devices simultaneously. They make decisions based on demand charges, real-time weather, and equipment constraints. It's brilliant. And when you combine that expanded thermal storage with intelligent, coordinated controls, the financial impact is just staggering. In markets that utilize time-of-use rates and demand charges, this exact system can achieve up to 90% savings compared to traditional resistance electrical heating. 90%! That is an absolutely massive cost saving for the customer and a vital, reliable load-shifting tool for the utility company. All right, let's turn the page to the next section of our new utility playbook, Sky Radiance and Low Energy Input Cooling. This is the perfect innovative cooling solution for the next generation of data centers. Because the massive power draw of data centers is largely driven by keeping things cold, traditional HVAC systems just aren't going to cut it anymore. Sky Radiance addresses this challenge head-on by combining two very distinct elements. It leverages a highly specialized passive radiative cooling film developed by 3M, and it pairs that seamlessly with a proprietary fluid management system from Thermal Energy HQ. By effectively bouncing the sun's heat away using this specialized film, and then intelligently managing the fluid exchange beneath it, this technology delivers highly effective cooling with an incredibly low energy input. It's just a prime example of rethinking old problems using advanced materials. And really, that brings our whole narrative full circle. Yes, for sure, utilities are facing a historic challenge right now. The load spikes from data centers are stressing our infrastructure in ways we literally haven't seen in decades. But by adopting that leave no stone unturned mentality we talked about and embracing new technologies like modular thermal batteries and advanced low-energy cooling, this crisis is actually becoming a true window of opportunity. It's a chance to completely modernize the grid, to rethink how we generate and store energy, and to attract a brand new, highly skilled workforce to the utility sector. As one professional recently put it, right now, this is absolutely the most exciting place and time for an electrical engineer. We are standing at the precipice of a completely modernized electrical grid, a grid where intelligent devices and innovative materials work in perfect harmony to balance out these massive new power loads. The old playbook is being thrown out and a new one is being written in real time. So as we look at the billions of dollars being invested and the brilliant engineering being deployed right now, what role will you play in building the next generation of energy infrastructure? Thank you so much for watching this explainer, and keep learning.